So now that we've examined the structure and functionality of the GCD microservice, let's go ahead and take a closer look at its actual implementation. And again, this is going to show how to implement the GCD controller and the GCD service class. And the focus here will be on the Java parallel streams framework. And as always, you can get this at the X3 project in my WebMVC folder in my Live Lessons GitHub repository. Speaking of the Live Lessons GitHub repository, here we are in the server portion. Now we're looking at the GCD part. Most of this is very similar. It has an app that's going to be the GCD app. The only difference from the one we saw with the Primality app was this points to the GCD microservice properties file, which gives a slightly different name, of course, and a different port number. So that's where those values come from. The GCD controller, no surprises here either. It's a REST controller that's auto-wired to the service. It's got a compute GCDs method with a get mapping and a request param, and it forwards to the service to do all the implementation part. But let's take a look at the implementation. That's the fun part in this particular example. So as you can see here, as we talked about in the previous part of the lesson, we've got a compute GCDs method that takes a list of integers. And the first thing it's going to do is it's going to make a splitterator. And we're going to look at the splitterator right now. So let's go ahead and click on the splitterator. And you can see here that a splitterator is a class that's defined as part of the Java Streams framework. And this case, we're going to extend the splitterator's abstract splitterator class. Abstract splitterator is an abstract superclass that's part of the splitterator's utility class. So you have a utility class that's got a bunch of other stuff that relate to splitterators. And one of them is the abstract splitterator class, which is going to be parameterized by a record called GCD param. We'll talk more about that in a second. So that's what the splitterator is. The implementation of the splitterator first defines a field, which will keep track of the list of integers that were passed from the client. And we also keep track of an index, which is going to be where we are in that M integers list. How far have we gone? And we're going to take a look at each element two at a time successively. The constructor just takes that list of integers and stashes it away in the field, and then also calls up the superclass just to initialize the superclass. And then the main method in a splitterator, all splitterators, is the try advance method. And this method is used to attempt to extract the next pair of integer objects from the list and return them as a GCD param. So that's important to understand. So we're going to return those things as a GCD param. So what it'll do is it'll pass back a GCD param if there was one to be found, we haven't seen before. And it basically passes it back by reference using this action parameter, which is of type consumer, which is parameterized by GCD param. So it's basically going to take GCD params and pass them back. The try advance method returns false if we're all done, which tells the streams framework we're finished, stop trying to convert anything into a stream at this point. Otherwise, if it returns true, it's an indicator to the streams framework there could be more params to extract, keep going. So the streams framework calls the try advance method. And the first thing the try advance method does, and it says, hey, have I gone past the end of this list of integers? And if I have, then we're done, and I return false. Otherwise, I make myself a new GCD param record instance, passing in the M index item of the M integers list, followed by the index plus one item. So we basically take two successive integers from that list, combine them together into the GCD param record, which you can see here has a first int and a second int. So it's another good old Java record. And we then call the accept method that will consume that particular GCD param and then allow it to be retrieved by whoever called try advance, which is the Java Streams framework. The next thing we do is skip over the next two elements that were just processed. So we process two elements, we skip forward by two, and then that'll get us ready for the next go round. And we return true to indicate to the Streams framework, hey, we're still going. Keep seeing whether there's another pair of GCD params to extract from this list. So armed with that knowledge, if we then pop back here to the GCD service, you can see what happens is we pass that splitterator to the stream support stream method. Excuse me. And stream support stream is a factory method that will make a stream. And we tell it we want to make a parallel stream here. So what we have now is we have a parallel stream of GCD params, and then we take each of those GCD params and we map them to the compute GCD method. And what that does is it takes a GCD param, excuse me, and it calls down into the mathutils GCD method with the two parameters, computes the GCD result, prints out a little helper message, and then it makes a GCD result object, passing in the param and the result. And the GCD result object looks like this. It's a record that has a GCD param as its first field and an int, which is the GCD, as its second field. So this is just showing you can nest records within records. So that's compute GCD. And of course, we end up then with a stream of GCD results, and those are converted into a list of GCD results, which are what's returned from this particular method. So again, at the risk of beating a dead horse, this is, I think, a slightly more clean way of doing concurrency than the approach we saw over here with Java structured concurrency, which just has this extra step involved in being able to first scatter everything out using the submit method on the executor, and then gather everything back at the end of the block, and then converting the list of futures to prime results into a list of prime results. But again, you may have a different point of view on that, and that's perfectly fine.